Hi, everybody. This is a boring talk. So there is a beautiful beach outside, nice weather. This is going to be boring. So if I were you, I would look for something else to do in the next 40-45 minutes. But fact is that it's a hard job modernizing applications, but someone has to do it. Also because it was brought to my attention recently, something that really shocked me, and then a few weeks later, at the latest Microsoft MVP Summit, the message was easy to perceive between the lines of what was said. So at this time, cloud giants, in particular two of them, Microsoft and Amazon in particular, are fighting each other, a sort of business war, to bring as many large applications on their own cloud. And the interesting fact is that apparently, in many cases, they are going to pay themselves the burden of bringing legacy line of business, usually very large apps, to a newer version that can fit on their respective clouds. So this is the scenario where this presentation, strategies and platforms, and even patterns to modernize legacy application makes sense. When we think of software, we believe that software is something that once is written, compiles, is deployed to production, it stays there. Immutable. But unfortunately, no matter its physical, immutable nature, software is subject to the action of time like any other living organism. And the interesting thing is, okay, what is the reason that makes software legacy? There are, if we look in this list, a bunch of types of applications, desktop, web, client, server, covering today a number of obsolete technologies that we can classify as legacy. So the taxonomy includes Visual Basic 6, includes also ASP.NET Web Forms, but also AngularJS, which is the ancestor of the modern Angulars, but also older versions of Salesforce, COBOL, Power Builder, and the list is essentially, could be longer. But what makes software outdated? In a sentence, the inability to keep on any of the following aspects. Is the current software still able to solve the problem it was originally designed for? Any problem lives in a business context, and the business context evolves. So is the software that is working today still working tomorrow, or the software that was working 10 years ago still working today, still able today to solve newer or changed business problems? Then security, another aspect of life, of digital life that changes, is never standing in the same position. So the software is still able to fulfill constraints and requirements to make it qualify as secure. Innovation. There is competition. And you had a great idea, you conquered a significant share of a market, but someone else looks at you and gets a better or different idea. That's innovation. So the solution you had in place is still able to keep on the innovation pace. Scalability. We're having success, and having success is a problem because it may take you to grow the ability of the application that currently runs to accommodate a larger user base and data volumes. Laws is another scenario that never stops. So compliance to new regulatory requirements. And then the business grows, the business evolves, whatever it is. New companies buy each other. And when a company buys another company, the next problem is integrating their software environments. So interoperability becomes another aspect that makes software critical. Takeaway number one, originality within continuity of business. What makes software modern? Modern is a snapshot. So today, what makes today's software modern? For sure, cloud landing. I personally work for a company that operates in sport tech, in particular in tennis. In particular, my role is that of architecting the entire software and IT infrastructure that takes information about the data points from the tap of the umpire on court, on a tennis court, up to back 365 for you to bet and to lose your money. So it's me that in tennis allows you to comfortably lose your money with bettings. And in this journey, in this industry that I started right after the beginning of the pandemics, when I went from hero to zero overnight, like probably everybody else in this room, at that time, the challenge was replacing an application, 10-year-old app, which was desktop-based. So imagine every single tournament, people going around with the USB drives, USB keys, to deploy on 10 different computers the latest version of a piece of software. So landing on the cloud was mandatory, and that is an example. But imagine every application today, to be called modern, must live within or around on top of some cloud. And also it must have a user experience that is intuitive and responsive, not much in the resize of the windows and the user interface, but responsive in terms that it allows to implement effectively and in a smooth way business processes. User experience these days is much more about adherence of user interface with business processes than in making ergonomic and comfortable the clicking of the various buttons on the various screens. We had, anybody heard about AI? We had also AI. In particular, we also had generative AI, which is much more than plain machine learning, enabling a number of scenarios and is re-evaluating completely from scratch the role of chatbots. You can do magic with the ability of generative AI. In particular, you can raise up significantly the level of which you can communicate as a user with a piece of software. Not just structured forms. In the end, that's what we do. Okay? The only way we have to interact with a computer over the web is an HTML form, which has a fixed number of input fields restricted by content, and that's it. With the new generation of chatbots, of chat-based generative AI-driven applications, we can use by voice, using the mic, or typing free text, regardless of the speaking language. This is innovation that can make our applications, especially those that face a large base of users, require. No application can be managed and maintained in the cloud with all this level of complexity without good DevOps practices, without analytics, data being collected automatically, Maybe we don't have take the time to analyze and really make decisions out of that, but we must be able to capture the data. Otherwise, there is no chance for anybody to move to the next step. What is the point about scalable architecture? What is really meant by scalable architecture? Whenever you think, plan a new application or revamp of an existing application, oh, we want it to be scalable. Are you going to be the next Netflix, the next Amazon, the next Microsoft? Okay, good for you. But in general, the point is behind the translation to a human language of the expression scalable architecture is mere foundation in the new app for sustainable growth and continuous operational efficiency. So build it not to be today Netflix to support million concurrent users, but keep in mind that the app has to be designed in a way that is flexible, possibly with watershed compartments since day one, and grew maybe through complete overhauls, but grew without starting from scratch and going with a new big rewrite. But to be really, really, really modern, an application today has to have a lot of JavaScript. If it doesn't have JavaScript, it is not perceived as modern. Now, I like to call this research for ways to modernize applications as the research of patterns of software fitness. In much the same way we look for our own individual fitness. I would say that there are overall two different classes of approaches. One is the canonical, the ordinary lift and shift, which is implemented usually through rehosting, replatforming. The other one is much more ambitious, the big rewrite. Here is a mere matter of money, budget. You put on the balance, on the scales of the balance, your budget and everything else, and then the balance wins. The purse string usually wins. If you blink at a big rewrite, the thing becomes a lot more ideological. You have essentially in this area a couple of approaches. Buzz-driven, which is primarily ideological. We want to follow the best practices. Our company has as a policy that we must fulfill. We must capture the best practices no matter who defined what best practice really means, but as long as it's best, we want it. That's purely ideological. And then there is a, well, more pragmatic approach in which you mix up gears and heart. Big rewrites are a delicate topic, okay? They're, especially from the perspective of executives, people who really has to put the money on the table. Behind the idea of a big rewrite, there is a hidden message. If they don't go for a big rewrite, the message that is being sent to companies and stakeholders is, well, we are catching up. We have issues, we know, but we are trying to fix things quickly. That means that we don't have a long way ahead. We are making small steps every day, short distances to walk at any time, with the hope that the finish line is always in sight. We have the next finish line close to us. It's not really the final finish line. It doesn't matter as long as it's a finish line. We are the guarantee that we move from one stable stage to another one stable stage. The big rewrite, on the other hand, is everything is new from scratch. And from the perspective of executive, it's like close your eyes and go. Like stabbing in the dark. Success is a non-zero, but failure also is an option. And the message we always heard from top managers is failure is not an option. With big rewrites in software, failure is an option. And they don't usually like this scenario. Now, lift and shift. The simplest scenario of bringing an app, lifting an existing app from the scenario, the environment where it lives, to a cloud, simplified one of the very, very basic situations where you move a LAMP app, Linux, Apache, MySQL, PHP, from a physical, local server to an Amazon, for Amazon as an example, cloud, where you get an EC2 machine, a database, and it's essentially nothing more than changing a DNS record at the end of the day. Very easy, you are on the cloud. Nothing has changed, but you can go to your stakeholders and say, we are now on the cloud. So goal number one, achieved. Here is another example, replatforming. So it's not just changing the host, but it's changing the host with some extra work all around. Suppose you have an ASP.NET Core application. You can replatform that. For example, expanding this monolith into an app service container that incorporates some of the features originally in the single server. You can still maintain Azure. You can build all around an ecosystem of additional tools like a blob storage, Redis, App Insights, to take advantage of cloud services you find all around, and CI/CD to deploy in a possibly highly automated way. It's much more complicated, however, the replatforming step, if you have to go from here to here. If you don't have in the beginning already an ASP.NET Core, because moving from the .NET Framework 4.x to Core, well. Personally, we did it quite a few times, and we tried the approach of as long as it recompiles and start from scratch. We experienced both. We still have applications in production in our company I would say that the products that are flagship products have been ported to Core following the pattern as long as it recompiles. We are now rewriting from scratch the most remunerative of our products, but it's being built from scratch, from the grounds up. So this move, if it involves you. So when the replatforming involves change of development frameworks, that's not trivial. And yeah, it's really up to you. It's really up to the company, to the gut feeling of people to make the decision between as long as it recompiles or from scratch. Another example of going from scratch is a plain platform upgrade. Suppose you live in Salesforce space. There's a new version of Salesforce, and it's just essentially a one-to-one kind of mapping from the old framework, the old service, to a newer service. So for example, it could be from Visualforce UI to Lightning UI components, from custom BizLogic to the same BizLogic re-implemented using Flow and Process Builder, and a different way to connect to external data sources. Big rewrite. If I have to summarize notes about advices, converting existing code, as long as it recompiles, is not my favorite approach, even though in my working environment I had to accept this situation a couple of times. But also the people who went on with this project at the end of it said, well, it would have been probably better restarting from scratch, rethinking every single use case from scratch. It's a matter of time, it's a matter of getting the green or the yellow light from management. This is another piece of advice I would set in stone. Don't be overambitious. One thing at a time. Don't be overambitious. I will have later a slide of popular failures. Failure is an option, and what all that failures, resounding failures have in common is overambition at the beginning. Technology stacks as small as possible. Avoid putting new technologies, every new technology, one on top of the next. You need caching? No, but let's put Redis. We need a message bus? Probably not. Okay, but let's put some sort of service bus because you never know. Avoid that if you have the chance to do that. And then when you have something to show to people, migrate users to the new system, one team, one piece at a time. Never have a click day or a new day in which the whole system goes online. When to call for a big rewrite? Suppose your role is that of an architect, of the technical advisor of a company. You know that your company has line of business apps, older enough to justify a rewrite, or you have a gut feeling that that app would be ideally rewritten from scratch. But you have to go to some of your bosses and justify your gut feeling. How will you justify gut feeling? Because it's something you have inside. It's not something that comes out clearly from your brain. So here is a quick list of aspects that could numerically justify a call for a big rewrite. Developer ramp-up time. What does it mean? It means how long it takes for a new developer to become proficient in the existing line of business app. Proficient means the time it takes for this new person to make the first commit you trust. For a new-buy developer, fresh from university, if it's more than a couple of months, it's probably not just the developer in itself, it's the entire ecosystem of application that has issues. 3 weeks for mid-level, 1 week for an experienced, more than 2 days for a seniors. These are my numbers, but feel free to disagree. But anyway, I suggest you create a table like this with your own numbers. This is numbers that you can put in front of an executive for him, her to mentally transform into items on a budget. Okay, I forgot it. Oh. Deployment cannot be automated. Issues here. Obvious. Simple bugs takes too long to fix. New features takes too long. My experience, it took me 4 hours to change a label. Yes. Yes, it took me 4 hours. I couldn't believe when a guy who is in between these two levels spent 2 days unable to change the label. I said, no, should I fire you? maybe. I went there, let me see this. It took me 4 hours. Honestly, it took me 4 hours. It was just a stupid label to change. Because the interconnections between I discovered that something like called a JavaScript event bus was used. I didn't know that something like that, the human perversion could reach this level. A JavaScript event bus. And also this aspect here. Too many use cases on too few screens. This is more related to processes, to business processes. But it's another aspect to put on the table, because essentially this tends to be the mechanics, the trigger for new bugs. And if even a simple bug takes too long to fix, these are all arguments that in front of an executive take them to turn into budget items. So these are all points that could be used to call for a big rewrite. So today, when it comes to approaching a big rewrite project, we want to use Angular or React or microservices. We want to have a beautiful dynamic front end with its own back end now. The front end for the back end for the front end is wonderful. Another example of human perversion. But anyway, there is a front end here. It doesn't matter how you end up to produce it. And then at the very end of the day, that front end talks to a back end, in which at some point there is a barrier with an orchestrator with load balancing. And behind that, there are pieces of code doing things in ASP.NET Core, in Python, in Node.js, and so forth. So this is the overall architecture, and the connection goes through REST API or maybe GraphQL. And all around, on the back end, you have, beyond the orchestration front-end layer, you have a storage, AI, event bus, cache, blah, 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 blah. Cloud services. So microservices. You know, the question is, what is the size? How big is micro, or how small is micro? The size counts. The scale of microservices pattern. Now imagine that you are here. You have this big block, okay? Single line of business application. I go for rewriting this, and I want to use microservices, because that's all that the entire world is doing. So a bunch of, looks like a piece of cheese, but mental cheese, but you know. Microservices here. But now, this is a single line of business app. Now let's take a larger view, a broader view. Where does this line of business app live? What is the content of the enterprise ecosystem where this app lives? Imagine those maps that in touristic places you find, they show you the map of the city and then a red button. You are here. If you are here, you see what you have in front of your eyes. But you are a point, a red dot in a much larger map. Here is a much larger map. This app could be this one. But it's surrounded by 10, 20, 30, usually an interesting size of application for a significant enterprise ecosystem. It could be 30, 40 different apps. We are not as a large company, something like 100 people, plus as many freelancers. And we have about 20 different apps in our enterprise ecosystem. So 20 things to maintain, like app services, mostly app services, somewhere on Azure. And each of them is one line of business app for us. So is it one app that you are rebuilding? So are you constrained in the physical boundaries of one app, or are we talking about the enterprise ecosystem? What is the scale? Because as long as we focus on this app, then the microservice pattern is just about how you decompose the use cases of one app into more manageable pieces. And are you really thinking 3, 5, 6, 7, that 15, you need 15 app services for one app? Serverless, it depends. Serverless says that every server, every function, every lambdas is a stateless operation. But I don't expect 15 functionalities in a line of business app to be 15 single actions. So any of those realistically is much more than a single function. So even serverless may or may not be the right way to go. And any of those should be an app service. Any of those should have its own database. Crazy. You're crazy. No way. But it's different if we look at this same points of microservices in this perspective. Is any of those a standalone service? Yes, it makes sense. Does any of those have their own database? It could have sense. Yes, sure. So what is the size of the microservice? Is this red block, red circle, or any of those blocks? Now, in the enterprise ecosystem view, any of the individual components at the highest level of abstraction could be internally split into, okay, microservices. And then the overall thing is hundreds of app services, tens of app services, tens of different databases. It's so easy to say microservices. Sometimes microservices is good, absolutely. So I'm not here to destroy half of the software industry that makes money out of microservices, but I invite you to consider the point of the scale of the pattern, distinguishing between a single cloud-native app and an enterprise ecosystem. So when it comes to moving to a new app, I would recommend a pattern called, that I decided to call Isola at Impera. So take any block that could be isolated functionally from an existing monolith. It doesn't matter how big it is, as long as it could be disconnected and connected then using an explicit API. That gives you a monolith broken up into just a few separate pieces, isolated. So you isolate and then rule their behavior. Another way to call is code sandboxes. The largest chunk of functionality that can safely be put standalone and seen from the outside, it can look like black boxes. And those black boxes communicated through a new, well-documented API forming overall an interoperability layer. Add relevant integration tests. I'm not a big fan of tests. I hate unit testing. But I love integration tests. It's all about integration tests. Automated or not, it's all about integration tests. And repeat. Found the first, try if a second. You've got a partition of 3 pieces. Okay, go further and see if any of these 3 pieces could be further broken up into a larger number of features. This is the essence of Isola at Impera. Now, instead, let me give you another perspective. Imagine now that you are facing not an existing piece of software, but you are facing a business domain to model via software. The first step, we learned it at university, logical decomposition. How many, I was looking for a fancy name, macroscopic functionalities, use cases we can identify. We have a list. Then the next step is, once we have the logical decomposition of things to do, any of those aspects is standalone by design. The next is, okay, now we should find a way to turn these specs into running software. So microscopic functionality, microscopic service. And service here just means a software version, an implemented version of the piece of software I identified out of analysis. And then it's so easy. You have 1, 2, 3, 4, 5, 6, 7, and so forth, pieces of independent pieces of software. It's about deployment. We can go with a monolithic deployment. So these are class libraries, these are packages of modules of any sort in a single unit of deployment. A single app service, maybe. If you want, once you have this independent pieces, why not going with a microservices deployment in which you just group together subset of decomposed functionalities. But because you started from here, you are guaranteed that whatever you end up putting as a unit of deployment has no inner, invisible, hidden dependencies. It's clear, it's testable, looks like a sandbox from the outside. So if at some point, say, from a monolithic deployment, you realize that this piece of function is called with a different rate than other modules, and you want to optimize for performance the overall behavior, you can take this out of the monolith and deploy that individually as a specific dedicated service. And you can reach out any level of granularity you think is worthwhile for your app. So from a service, you can even go towards microservices. But it happens under your control. And none of the today's popular microservices architecture were so immensely, so harshly distributed in the beginning. So every successful microservices architecture of today was in the beginning a monolith, starting from Twitter, from Netflix, and Amazon. I was in this industry when Amazon in 2004 launched. There was if you can even find on the web the email, apparently, that attributed to Jeff Bezos, in which he was advertising what was, at the time was called a service-oriented architecture. Amazon started this trip 20 years ago. Okay, so today, concretely, teach old web dogs new tricks. You have an old dog over the web. Concretely, you have any of these things that you can call from the front end on the Microsoft stack at least. There. So all you have to do is putting something here and rewrite this. But essentially, the connection from the front end to the existing back end and vice versa. If you don't have the web, you have today Windows, maybe, Windows Presentation Foundation, maybe. You can still do the same, but you need some specialized things at the front end. There are protocols, commercial protocols, proprietary protocols and platforms that help you achieving this. And then to finish off, failure is an option when you try to achieve big rewrites. From the Mozilla rewrite that produced Firefox as an output, but at the cost of the death of Netscape. That was the first example. Microsoft also gave a great contribution with the Windows Vista failure. But Target Corporation, a major American retailer, did it twice. They failed rewriting their retailing system for the Australia market. And then for the Canada market 10 years later, same mistake, but in Canada they lost $2 billion and had to close business in that country in 2 years. And finally, here in Europe, Lidl, the German supermarket chain, that spent 7 years of paying invoices to SAP just to figure out that the best thing they could do was going back and adjust their existing retailing system that in 2011 was evaluated limited for capacity. Yeah, they are still now, in 7 years in 2018, they started modernizing in a different way instead of rewriting from scratch the same system. So when you try to achieve modernization, failure is always an option. Thank you very much for your time.